Hi everybody, I'm Steph from Simply Rhino and I'd like to welcome you all along to today's webinar. This is the second in our current series of 3 webinars where we're looking at product design with Rhino for Mac. Our presenter is Phil Cook. Phil is a product design professional and Simply Rhino's senior trainer. As we go through today's webinar, if you do have any questions, then please type them in and send them over to us. If we can answer them during the webinar, then we will, or we will perhaps answer them in a Q&A session at the end, if we have time. We're going to record today's webinar and make a recording of that available via the Simply Rhino website. We'll host it on the Simply Rhino for Mac YouTube channel, and we'll make it available as soon as we can afterwards. So that's all from me. I'm going to hand over now to Phil for the presentation. Over to you please, Phil. Thanks everyone.
Morning everybody. In this webinar we're going to carry on from the webinar we did a couple of weeks ago, and we're going to create some surfaces and solids from the curves that we set out in the last webinar. So just to recap, what we did was originally we had a 2D reference. We created some 2D curves from the reference, and then we laid out those 2D curves in their 3D positions. So the aim was that we had a rail here, which I'm highlighting, to which we appended some cross sections with the aim of sweeping these cross sections along the rail to create surfaces or solids. So one of the commands that we used to do this was an important command for laying out curves for sweeping, which was orient perpendicular to curve. This is particularly important for sweeps because it's always important to make sure that the cross sections are aligned correctly perpendicular to the rail, and we do this in order that the sweep is going to build correctly and the cross section stays constant throughout the sweep. So just to recap on how we did this, and I'm doing this because I need another cross section here, is that we pick the cross section in question, we go to the transform menu, orient, and perpendicular to curve. Pick the reference point that we want to be sitting on the curve, and then click on the curve onto which we want to orient. And you'll see that as I move my cursor along here, that the cross section stays perpendicular to the rail. There's a copy option on this command that allows me to put more than one element on the rail. However, I don't really need these additional sections here. Okay, now the red sections here represent the lip in for example, the bottom moulding that locates the bottom moulding into the top, and the lip is set inwards from the outermost boundary of the lower moulding by a small distance, let's say 0.4 of a millimeter. So what I need to do is to actually move this red cross section along the rail or inwards on the rail by that distance. To do this, I can use the move command. But I can use also the direction constraint here. So I can snap near and then hit the tab key, and you'll see I get a white line here which is locking the direction of that movement. Then when I've established the direction, I can type in the distance, 0.4, and hit enter to accept that. Now in this case the movement is going to be a linear movement when we're using that direction lock command. That's okay in this instance because this rail is built up of 2 lines, and then this sort of S-shaped curve here was a curve blend that was created between them. So as long as I'm only moving the cross section along the straight portion of the rail, then this command works well for me. So again, it's pick the cross section in question, transform, move, find the near snap here, hit the tab key, and then type in the distance, 0.4. Okay, so now my rails now my cross sections are set out correctly, and I can start to create some surfaces and solids. Solids are a good bet for concept models if one of your aims is to move to rapid prototyping. So if you create a nice watertight solid model in Rhino, then it's very easy to create a good watertight STL mesh. And so another thing here is that what we're trying to introduce here is the idea that in Rhino and in surface modeling in general, the idea is that you do a lot of work with initial set out curves, and then the surfaces and the resulting solids really just come as quite simple commands. So a lot of the work goes into the setting out of the curves, and then everything else then becomes fairly straightforward. So now I'm going to start to create some of the surfaces, and I'm going to use the one rail sweep command, where we take a rail and then we pick a cross section and then we sweep the cross section along the rail. When I have a closed cross section, I'm asked to choose a seam point here as an additional command. You won't see this if you sweep an open cross section, in this case the seam position for me here doesn't make an awful lot of difference, so I'll accept the default here. We'll see a preview of the sweep, and we'll have some style options here. We'll accept the default freeform option, and we also have some options on what we want to do with the cross sections. Here I'm going to say do not simplify, which is generally the best option to choose here, which will take your existing cross section and sweep it along the rail. Optionally here I can choose to rebuild that cross section with a known number of control points, or refit to within a new tolerance. Generally, if you build the curves correctly, then do not simplify is the best option. Then I'm going to hit the sweep button here to finish the command, and you'll see that my sweep is built here. Okay, next up you'll notice that the sweep actually produces an object with open ends here. This is because essentially sweep is a surface command, so it doesn't create solids. However, because these ends are planar, it's very easy to just cap these. So I just pick the object here and I go to solid and cap planar holes, and then you'll see that I can create a solid object from my original open poly surface. Okay, so for clarity now I'm just going to hide this object here. So I can do this either by going to the menu here, so edit and visibility and hide or show, but it's easier to use the shortcuts. So on a Mac, to hide an object it's Alt and H, and then to show back the object it's Control, Alt and H. It's always very confusing if you use both a Windows and a Mac. So I'll just hide that object. And then let's now sweep the red cross sections. Now here I need to sweep two cross sections because I need to constrain the length of the sweep to that which is between the two cross sections. So I don't want to sweep across the whole length of the rail this time. So same command, sweep one rail, pick the rail and then pick the two cross sections. Here the seam position is more important now. We want to make sure, I'll just redo that, sorry about that. We want to make sure in this instance that the seam positions here are coincident. We'll get there in a moment. Okay, so you can see here that our arrows are in the same relative position on each of the cross sections. This is very important, otherwise the sweep will twist if our seams don't align correctly. We then go into the preview and then accept the default proposition again, and then cap this. Okay, so then I can hide this and then sweep finally the lower cross section. Okay, so I can now turn the visibility off of my curves and hide in the other objects. I just want to cap this object here. Okay, so you can see we've got our basic shapes here. Next up, I want to look at creating some fillets, and whether we have solids or poly surfaces with joined edges, we can use the solid fillets. So this adds fillets or rounds onto the edges of our objects here, and let's look first of all at the bottom of the handset. So let's just hide these portions here and look at the bottom of the handset. So I want a larger radius in these four corners here than I have along the other edges. So just want to make sure that I didn't actually drag that object there. No, that's good. So solid, fillet edge, and fillet edge, and I'm going to type in a radius here of 3.4 millimeters. It's important to input the radius before you pick any edges, and then I can pick these four edges here and then enter, and optionally here I can preview those edges. So let's do this with the preview. Let's just do one edge here with the preview. So here, once you see this dialog here with the handles, I can select preview here and I'll see how my fillet is going to build, and if I like the look of that, I just enter or right click to accept. Again, I've got my Rhino here set up to right click to repeat the last command. This is kind of a standard behavior for Rhino on Windows, and it's a pretty good way of repeating the last command here. So right clicking repeats my fillet command here, and I can just go around the edges and fillet. Okay, so now I'll pick the top edge and I'll put a smaller radius, let's say 2 millimeters, around that. Actually it's the bottom edge, so I'll pick this edge here and put a smaller radius around that. So I'll change my radius to 2. Now to save me picking all of these edges here, I can actually use the chain edges option here. I can choose the setting for how I want to define the continuity of the edges, and I've got this set for tangency, which is the default, and this allows me to just pick one edge here, and all the other edges that are tangent to this will propagate. So this makes it very easy to fillet around a complete edge. Okay, so we just see that preview. There's sometimes a little bit of a lag when we're previewing the radii. Just check that my corners look okay. They look fine, and then enter to accept the result of that. Okay, so that looks okay. Now, if I want to check the surfaces here, okay, we get a bit of a look at them here in shaded mode, or possibly here even in rendered mode. But if I actually kind of want to just get a bit better feedback on the quality of the surfaces here, then I can go to Analyze and Surface and Environment Map. And the Environment Map plays a reflective surface over my Rhino model, and I can choose the type of surface, the type of reflection that I use on this. And this is a really good initial tool just to check the integrity and the quality of your surfaces. This would be the kind of first analysis tool that you would use on your Rhino surfaces. So this is Environment Map, and this is from the Analyze menu. So now I'm going to fillet the remaining objects. So I'll show these back in. I'll just hide the top for the moment. And let's fillet these corners here. So here I want to set a radius of 3 millimeters. So because I've got a 0.4 step here that I'm trying to create, so I'll do this on these corners. That looks good. And then as our ultimate aim here is a solid, one of the things I'm going to do now is to take these two objects and actually join them into one solid volume. And I do this with the solid union tool, which is a Boolean union tool. So solid and union, pick the two objects, and this will intersect the objects and create a manifold solid from the result. Okay, so you can see here, if I look into this now, it's removed the kind of area where these objects were overlapping. Excuse me. So I've got one solid volume now, solid manifold volume. So next up, let's have a look at the top. So I'll just show this in. Now it's possible when we're filleting to actually pick a number of edges, all of which have different radii. So let me show you what I mean here. So I can go to Fillet Edge. I can set my first radius to 3.4 and then enter to accept that, and then I can pick these edges here. Then, without pressing enter, I can select my next radius, 2 for example here, and enter to accept 2, and then I can pick these edges. And then I can enter to get into a preview mode, again we'll have a bit of a wait for this, and you'll see that we can build the radii of different sizes here. Now on this type of geometry the result is going to be very similar to picking the edges singly as we did before. Picking the individual radii singly as we did before. However, on more complex geometry, picking the edges all in one go can sometimes give favourable results. So I'm just going to accept this here and then show in the remaining geometry and then union this together. Okay, so we've now got a nice solid object that's ready for adding some detail to. So just check this with an environment map again here. That looks pretty clean. So that's going to be the object on which we're going to add some detail in the next webinar. Now, just to go back a couple of steps now, in fact, if I just hide this geometry here. Still getting mixed up with these shortcuts here, and turn my curves back on. One of the things that's interesting about Rhino is the ability to use history when we create objects. History now in Rhino is hooked up pretty much to all of the modeling commands, or all of the surface commands now in Rhino. And the idea behind history is that it's not a parametric history that you might see in solid modelers. It's an association, for example, between curves and the surfaces that are the resultant from those curves. So in other words, if I model for example a sweep with history turned on, then I can adjust the curves and the surfaces should update. So let's try this now. So first of all I'm going to turn on my history here, and you'll see the history lights up here or is emboldened here, and then I'm going to run the sweep one rail command. So I'm going to pick the rail and then the cross section and just accept the default settings here. Okay, so sweep pretty much the same as before. Now if I pick my rail here, for example, and turn on my control points, for my rail. So if I pick one of my control points now and move that control point, for example, you'll see that the sweep updates. If I switch to full view here, you might see this a little easier. Okay, so this is kind of quite a neat way of being able to model. So I should be able to take either of the curves that I've swept with here and history should update here. So if I pick this curve, which is what I swept with, and I, for example, scale in one dimension here, I could just widen this or make this narrower, and again history would update. So I can use, you know, both of these curves to change the shape. Now you have to be very careful when you're using history, to model with. It's possible to kind of take these things to their extreme, and you also have to be careful about when and where you break history. Now, this is reasonably straightforward, but probably not something that we've got time to explain at the moment. So I think the best advice with modeling with history is to first of all make sure that you have copies of the geometry that you want to adjust with history in case you make mistakes, and secondly to use history judiciously. So just kind of don't try to initially do too much with history, but just use it where you're going to get an immediate benefit from it. Okay, so that's I guess what I wanted to cover in this webinar, and I'll hand over to Steph and Paul for any questions you might have.